Hello everyone, this is Himabindu from the Department of CS IT. So today in this video I would like to explain about the regular expressions. So in previous videos we have discussed what is meant by regular languages and what is the difference between the regular languages and regular expressions, how to form a regular expression and what are the regular sets and what is the difference between the finite automata and the regular expression. And now in this video, how to form a regular expression and what are the identifiers involved in this regular construction of regular expression, we will see. So first one, what is the regular expression? So we already discussed, but we are elaborating this one. Say a regular expression is a declarative way to express the strings what we want to accept. So what is the way of representation of strings that should be represented in the regular expression? So it is a declarative way to express the strings what we want to accept. And any terminal symbol belongs to epsilon symbol, including empty and null, also a regular expression. So these points we already discussed. So including the regular language which is having the empty and the language which contains the empty and null also, it's a part of regular. We can form the regular expression. So the operation, and third one is about the operations which are involved in this construction of regular expression is also the operation performed for the two regular expression for will get the regular expression again. So what are the operations for the regular expressions? So union operation, concatenation and iteration or closure. So these are the three operations which are performed for the regular expression, and by performing these operations also we will get the regular expression. And next slide. So we'll see here are the examples, some examples how we are declaring the regular expression with the regular sets. So here it is a regular, we'll take 0 plus 1 0 star. So what it contains, so here 0 plus, the string is going to be start with either 0 or 1. And after that 1 0 star. So here either it is a 0 or 1 we are starting, and also we will get 1 0. So 1 0. So 0 and also like this epsilon 1 epsilon. So here we will get this. So the language which says that it is a combination of either it is starting with 0 or 1 and with the form of 0, 1 0 1 1 1 0 0 1 0 0 and so on. Like this we have to form a regular language. It's a regular set for the regular expression. And here also the regular expression what says 0 many times and 1 0 star. So epsilon is star represents including this empty symbol also. And here so both the zeros are having the stars. So we will say, so first one should be there and 1 is there, and it is starting with either 0 or 1, either 0 and here ending with a 0. So starting is 0, ending is also a 0 and also empty symbols included. That's why we have written only 1. After that the starting is 0 and ending is 0, and in between the starting and ending we will get the 1 as a substring. And here, so here the 0 many times. So we have written 0 star. We will say that 0 many times should be started and ending also 0 many times we will write. So like this we have to form the regular sets for the regular expression. And here one more regular expression is 0 plus empty symbol, 1 plus empty symbol. So what are the alphabets which are involved in this one, in the sense alpha, comma 1, comma 0, and it's a combination of 0 1. 0 1, and there is no whole star, that's why we are not iterating this one. And AB star, so A plus B whole star. So A plus B whole star, the set of strings of A and B of any length including the null string. So here what is the language contain? L epsilon including. So we are declaring that the star. So star contains the language of star is including epsilon and so on, whatever the input symbol, say the 0, 1 and so on. So star, if we give any star, this one, that is nothing but we are including that language with the empty symbol. So that's why, so whatever the input symbol, we are representing the star in the sense we have to include this empty symbol as well as. And whatever the input symbol A, comma A, B. So A plus B. So we will represent, we will start with either A or B. So that's why A, comma B. And here A is many times. So it's a combination of AB, BB and BA. So like this we will form the language for the given regular expression. And one more regular expression, A plus B whole star and ABB. So what is this one in the sense? It is a string. This is a string ending with ABB. So this is the condition. The starting of the string should be start with either 0 or either A or B with the including symbol also, and the string should be end with ABB. So first what do we have to do? So here we are also including this empty symbol in the sense empty symbol starting and ABB. And first we are initiating with either A or B. So we are taking the A and a substring. And here B, we are starting with B and the substring. And A starting with AA and the substring. So both we are taking AB, the substring. So like this we form the regular expression. So with the regular set. And next 1 1. The set containing the even number of ones including the empty string. So as we already know that L, which contains L star, it includes the epsilon's empty symbol. So here this language and so on. So what is that one? Including empty symbol. And here also AA, so even length of A multiple times B, even length of B, and it's ending with B. So, and what is this main set contains? The set of strings contain the even number of A's followed by any odd number of B's. So here BB, 3 B's are there. So this is the odd length and this is the even length. So we'll perform this even length and odd length. So odd length, so here the odd length why we have taken, so these both 2 A's and 2 B's include the empty symbol. So empty symbol A, empty symbol B and B. So first one, if you take both empty symbols, we will get only B. So that way what we have written as a 1 B. And after that we are including AA one time and ABB. So ABB. And like this we have to add. So here we will construct a regular expression for this one. We will write this regular set for this regular expression is set of strings containing of even number of A's followed by odd number of B's. And one more regular expression. So AA plus AB plus BA plus BB. Here the string of AA and BB's of even length can be obtained by concatenating by combination of all the strings AA, AB, BA and BB including none. So here is the language which contains AA, AB, BA and BB, AAB, and these are all the formation of the language. And next slide is about the identities of regular expression. So what are the identities involved in this construction of regular expression in the sense? So epsilon R is equal to R epsilon is equal to R. So which means that epsilon R empty symbol R is equal to, either it is starting with epsilon or ending with epsilon is equal to r. So this is the identifier. So by using the epsilon starting and ending, we will get the same regular expression. And here the epsilon star is a epsilon is null string, and what epsilon star is also a epsilon, and empty string of whole star we will get the epsilon, and empty r is equal to r empty symbol we will get concatenation. So like multiplication 0 into 1 and 1 into 0, we will get 0 only. Like this, it's empty symbol plus empty symbol into 4. Regular expression into empty symbol, we will get the empty symbol only. And empty symbol plus r, so either empty or r, so we will get the regular expression r. And r plus r we will get, so if you combine both, we will get also a regular expression. And here r star is equal to, so if you start the whole star of r is after the middle of whole star, we will get the whole star r plus. So here nothing but r plus is nothing but it excluding that epsilon. So in r star we will get epsilon symbol and so on. Here excluding this epsilon, so epsilon is not included, and whatever the symbols are involved in this regular expression, so those symbols are represented. So this is the star and the plus differences. And one more, and these are all the identifiers. So r star whole star we will get again r star. So how many times of closure performed for the regular expression? So it is equal to the one time closure. And epsilon plus r star is equal to r star. And here p plus q r q p. So it is a equation p plus q. So we are performing the multiplication operation p into q, p into r, and q plus q r. And here also p plus q whole star is equal to, so if either p or q whole star, we will get p star q star whole star and p star plus q star of whole star. And one more, so our regular expression of r star epsilon plus r is equal to epsilon plus r of whole star. So either it is starting or ending, so equal to r star. And here r plus whole star, r plus epsilon of whole star, we will get the regular expression of star. And here also empty symbol plus r star is equal to r star. So p q star whole star is equal to p of q. So we are starting, and here it is starting and ending is both are equal. And r star plus r star r is equal to r star r. So these are the identifiers which are used for the construction of regular expression, and we will use this all the identifier will construct while proving that LHS is equal to RHS. Both the regular expressions are equal. We have to prove that by using these identities. So, and for the proving the identities of regular expression, we want this Adams theorem also. So, what is this Adams theorem? So, Adams theorem is popularly used to convert the given DFA to its regular expression. So, in this one, finite automata to regular expression we are converting. So, for this regular conversion, what we need in the sense this theorem, Adams theorem. So it states that let P and Q be two regular expression over sigma. So here the P and Q are the two regular expression. So this contains the input symbols and these are the two regular expression. So if P does not contain a null string, then so R is equal to regular expression R is equal to Q plus RP has a unique solution, that is R is equal to QP star. So for this one, we will prove that by substituting this equation. So we are taking RHS Q plus, instead of R we are replacing, substituting with the QP. So let's write first RHS. So here we have to substitute this. R is equal to QP star. So by substituting this one, R is equal to QP star P. So what is the common thing in the sense here? Q. Q of epsilon plus P star P star. So what we will get by using the identifiers epsilon plus P star, we will get Q P star. P star of P. So P star of P, epsilon plus P star of P, we will get the P star only. So here this is the identifier what we have to substitute. Instead of epsilon plus P star, we will get P star. So that is the what we have to by substituting this equation, like epsilon plus P star P is equal to P star. So we get this QP star. So we have proved that LHS is equal to by proving that R is equal to QP star. So like this, the Adam theorem is proved that LHS is equal to RHS. And what are the conditions to use this Adam's theorem? So to use the Adam's theorem, the following conditions must be satisfied. So the transition diagram must not have any epsilon transition. So epsilon transition in the sense like giving the input symbol from state to this Q0 to Q1. So there is no, this kind of transition should not be allowed by you for using the Adam's theorem. And there must be only single initial state. So initial state of the transition table which contains only one single state, one single initial state. So these are the conditions to use the Adam's theorem. Let's take this example and we will prove that LHS is equal to RHS. So here we have performed some regular expression. So we will perform by using the identities of regular expressions. We will prove that LHS is equal to RHS. So here first LHS is equal to 1 plus 0 0 star 1 plus 1 plus 0 0 star LHS 1 plus 1 0 star 1 0 plus 1. So here we have to prove this RHS equal to RHS. So there is a common thing. So what is the common thing in the sense? So here 1 plus 0 0 0 whole star is there. Here also 1 plus 0 0 whole star. So and here we will take off this common thing. So 1 plus 0 0 whole star from this equation. So commoning this one, we will get epsilon plus 0 plus 1 0 star 1 whole star and 0 plus 1 0 star 1. So after taking this 1 plus 0 0 whole star of 1, we have this equation. By seeing this one, so we will simplify this epsilon plus P star. So R star of R equal to what we have there, the epsilon of R star R, we will have R star. So like this way, what is the R in the sense? Here R is equal to 0 plus 1 whole 0 whole star of star. Sorry, R value is equal to this one. So by performing this substitution, what we will get 0, 0 whole star of 1. So R star, what is the R in the sense? 0 plus 1, 0 star 1 whole star, R star. And here, so after this operation, what we will get here, the common thing. So here what we have to take out this one in the sense. So here we are taking epsilon plus 0, 0 star of 1, and again the same thing. So same thing is there, so no need to solve this one. And same thing previously done. So epsilon plus 0, 0 whole star will get 0 star and 1, and remaining 0 plus 1 whole star of 1 whole star. So what is this one? It is the RHS. So by performing this identity substitution, we will get the LHS is equal to RHS. So this states that both regular expressions are equivalent to each other. Both regular expressions are equivalent to each other. So by substituting all these identifiers and using the concatenation operations, we will perform this LHS is equal to RHS. Both regular expressions are equivalent to each other. And these are the references. And in coming videos, we will convert the regular expressions to finite automata and finite automata to regular expressions in the coming videos. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.